Today we're going to take a look at 8.3, adding and subtracting rational expressions. To be able to add or subtract rational expressions, you really just need to know two things. Number one, how to factor, and number two, how to add and subtract fractions. So if we see a fraction like this, 1/2 plus 1/4, and you want to be able to combine these, the first thing you're probably going to say is we have to get a common denominator between the 2 and the 4. The common denominator that we would have would be 4, so we have to change this first fraction to get a denominator of 4, which means that we have to multiply that 2 by 2 to be able to get a 4, but when we multiply the denominator of a fraction by 2, we're also going to have to multiply the numerator by 2, so 2 times 1 gives us 2. And then we just go through, and once we see that we have the two fractions with a common denominator, it's just a matter of being able to add the numerators. 2 plus 1 is 3/4. So we're just going to take a look at being able to do this with rational expressions. The first example that we have then is just add or subtract. Identify any x values for which the expression is undefined. So again, we're talking about where would that denominator be equal to 0. So if we take a look at this, 3x minus 4 over x plus 3 plus 2x plus 5 over x plus 3. We have to make sure that we have a common denominator, which they're both x plus 3, so we already have that common denominator. We just have to add the numerators. So 3x minus 4, and then we're adding 2x plus 5. Combine our like terms, 3x plus 2x is 5x, negative 4 plus 5 is positive 1, and we put that over our denominator of x plus 3. And there's our final answer. The second part to this is where is it undefined? That means what is going to make our denominator equal to 0. That's where our expression is undefined. Well, for this first one, it's x plus 3. So if we set that equal to 0 to solve it, we would get a value that says x cannot be equal to negative 3. And then for the second one, do that same exact thing. We'd get the exact same number, negative 3. So it's only defined at one value of x. That would be negative 3. The second one, we really have the same exact thing. We already have a common denominator of x squared plus 2, so we can just go through and combine our two numerators. 2x minus 1 and 4x plus 4. This time we are subtracting, so maybe what we want to do is actually take that negative and go through and distribute that negative through. So we're going to make this really add, and then a negative 4x and a negative 4. So 2x minus 4x would give us negative 2x, and then negative 1 minus 4 would give us negative 5, and that's over x squared plus 2. When we go through and combine these, what we want to take a look at is if we see this numerator, once we actually combine them, if this numerator can be factored, we do want to go through and factor it to see if anything can be reduced, to see if anything can be simplified, which the negative 2x minus 5 can't be factored, so we can just leave it as that. There's our simplified answer. Whereas this undefined, this is where we need to set this denominator equal to 0. Since they're both the same, we really only have to deal with one of them. We subtract 2 on both sides, get x squared equals negative 2. When we square root that, since we're trying to square root a negative, this is where we get an imaginary number. And since we really have an imaginary number, we don't have any values of x that would make this an undefined value. We're not going to worry about imaginary answers here, so there are no values of x that would make this an undefined problem. The next thing we're going to take a look at is what do we do when we actually have denominators that are different. Basically, when you're talking about finding a least common denominator, you're talking about finding a least common multiple, just there within the denominator. The way that we do that for rational expressions, first step is we just have to go through, we have to factor them. And then once we factor them, we're just going to list the different factors that we see. We just have to make sure that this common denominator or our least common multiple contains each one of those different factors. So if we take a look at this first example, these are just two monomials, so we don't have to really worry about trying to factor them. We just have to take a look at the numbers and the variables and make sure our least common multiple contains everything within each one of those. So that means that our least common multiple has to contain a 2. It has to contain an x cubed, a y to the 4th, it's got to contain a 3, an x to the 5th, and a y to the 3rd. So let's start off with that first thing we said. It's got to contain a 2, but it's also got to contain a 3. Well, what's the smallest number that contains a 2 and a 3? Basically, what's the smallest multiple that we could use with a 2 and a 3? That would be a 6, because 2 and 3 both go into 6. Then for the x cubed, it's got to contain an x cubed, but it also has to contain an x to the 5th. Well, if you have an x cubed, that means you have 3 x's. X to the 5th, you have 5 x's. So if we have x to the 5th down here, that means that it's automatically going to contain 3 x's, so it's automatically going to contain the x to the third. The x to the fifth is the smallest number of x's that we can have to be able to contain the x to the third and the x to the fifth. We can do the same thing for the y's. Y to the fourth and y to the third. Well, if we take that bigger y of y to the fourth and put it down here, that means it's going to contain the y to the fourth. It's also going to contain the y to the third. So there is our least common multiple. We can do that same thing for this one, but now since we actually have 2 trinomials, we want to go through and factor it. Well, if we take a look at this first one, we see that that sign at the end is a negative, so we should have x plus and x minus. It's a 4, need to multiply to get 4, that would add to get a positive 3, should be positive 4, negative 1. We do the same thing for the x squared minus 3x plus 2. We take a look at that last sign and see that it's positive. That's going to tell us our signs need to be the same, but if we jump one sign forward, that's going to tell us they both need to be negative. And 2 numbers that multiply to get us 2 that are going to add to get us at negative 3 would be negative 2 and negative 1. Well, we just have to write out now a least common multiple that's going to contain each one of these, an x plus 4, an x minus 1, and then an x minus 2 and an x minus 1. So it's got to have an x plus 4. It's got to have an x minus 1. It's got to have an x minus 2 in it. And then it's got to have an x minus 1, which we already put the x minus 1. And when we say it's only got to contain one of those, this is just one quantity of x minus 1. This is one quantity of x minus 1, and since they each have just one quantity, our least common multiple only has to have one quantity of x minus 1. If this were an x minus 1 squared, meaning that it would have 2 quantities of that x minus 1, x minus 1, x minus 1, we would have to have a second x minus 1 there, so we'd have to square it. But since we just have the 1, we only need to have the 1 down here. And there's our least common multiple. And so this is really our first step that we have when we want to go through and combine rational expressions, or go through and add or subtract them, is we have to get that least common multiple, or really the least common denominator here. So we take a look here, x squared plus 3x plus 2. We factor this. We can factor it into x plus 2, x plus 1. This one is already factored into just x plus 1. Well, if we take a look between the first denominator and the second denominator, they both have an x plus 1 in them. So we don't really have to worry about that. But we have to have, then for both of them, we have to have an x plus 2. So really, this denominator is our least common denominator, the x plus 2, x plus 1. That means that we don't need to change around this first fraction at all. It's just going to remain x minus 1 up top. The second one, though, we've got to throw in an x plus 2 with it. So we're going to multiply our denominator by x plus 2. But when we multiply that denominator, that means that we have to multiply the numerator by x plus 2 as well. So we go through, multiply that numerator. It's going to be x multiplied with x plus 2. Well, we're going to have to distribute that to make it x squared plus 2x, and then in the denominator it becomes x plus 1 times x plus 2. Now that we have the common denominator, we just have to add our numerators together. So x minus 1 plus x squared plus 2x, really all we're talking about doing is combining our like terms. So we have an x squared, we have an x plus a 2x is going to be 3x, then we just have a negative 1, which is just going to remain as that negative 1. All over x plus 2 times x plus 1. Now when we combine these, we want to take a look. Can that numerator be factored? X squared plus 3x minus 1. Well, it's a 1 at the end, so we're not going to be able to actually factor that. So there is our final answer. Now when we take a look at being able to say, because we go back to the same question of where is it undefined at, where would that denominator be equal to 0? Well, if we take a look at the original one that we started with before we were going through and trying to combine this, trying to say can we factor it, reduce anything out, is here we have an x plus 2, x plus 1, x plus 1, x plus 2. So the denominators are the same, so we can just take that first one and say let's have that first one set equal to 0. X plus 2 times x plus 1 equals 0, or maybe we can just get right to the point to say x plus 2 equals 0 and just x plus 1 equals 0. Those are the individual pieces of the denominator. Maybe we're comfortable enough with just saying to begin with, when we see the x plus 2 in the one parentheses, that means x cannot equal negative 2. We see the other one in the parentheses, that means x cannot equal negative 1. And there's the two values for which the expression would be undefined. I would like you guys to attempt B on your own. Pause this for a minute, try it. We need to get the common denominator first, and then once you get the common denominator, you're actually going to be able to factor the numerator, and when you factor that numerator, it's actually going to be able to cancel out. So pause it for a second, try this, see what you can get. The answer that we should get for this once we actually reduce it, is x minus 6 over x minus 3. And our values for which this is undefined would be negative 3 and positive 3. Because again, we're talking about before we reduce it, where would that denominator be equal to 0? When we talk about being able to do this with subtraction, it's going to be the exact same thing. We got to get the common denominator, and then with that negative sign, we're probably going to want to go through and just distribute that negative. So we start off by going through and simplifying or factoring that denominator. It's x squared minus 4. This is a difference of squares, so we can factor it into x minus 2, x plus 2. Remember, when you take a look for difference of squares, it's can you write this thing as a perfect square, can you write this thing as a perfect square? Well, x squared can just be the quantity x then squared. 4 can be the quantity 2 squared. And there's our subtraction, our difference. That's how it becomes x plus 2, x minus 2. Well, if this denominator has an x minus 2, x plus 2, we know that our least common denominator needs to have both of those. And this one just has an x plus 2. So it already contains part of that. It doesn't contain the x minus 2, so we can throw in that we're going to multiply this by x minus 2. We don't have to change that first one again. So we can leave this first one as 2x squared minus 16 over x minus 2 and x plus 2. And then we're going to do that same thing for the second one. But now we actually have to multiply this out. We know our denominator is going to be x minus 2 and x plus 2, but now we need to distribute this. So we distribute x times x times negative 2. That's going to be x squared minus 2x. Then we do the same thing with the 4. 4 times x, 4 times negative 2 is going to be plus 4x minus 8. We combine our like terms there. We get x squared plus 2x minus 8. Now to subtract these, easy way again to subtract them is to distribute that negative sign through. So we're going to turn this into a positive and just change all of our signs. Negative x squared, negative 2x, positive 8. And now let's just combine our like terms in the numerator. 2x squared and negative x squared is x squared. We just have a negative 16, so we can go to the x's. Negative 2x squared, and then negative 16 and positive 8 will give us a negative 8. Then in the denominator, it's x minus 2, x plus 2. Well, our numerator, x squared minus 2x minus 8, we want to take a look to say, can we factor that? Can we come up with the two numbers that multiply to give us 8, that add to get us a 2, which we can go with x minus 4 and x plus 2, over the x minus 2 times x plus 2, which we see that they both contain that x plus 2. They both have binomials being multiplied by x plus 2, so we can get rid of both of those, leaving us with x minus 4 over x minus 2. There's our simplified answer. Where is it undefined? Because we also have to worry about that. Well, it's undefined where our denominator, again, is equal to 0. Well, our common denominator was x minus 2, x plus 2, so what values would make that equal to 0? Would make that equal to 0. And for that first one, that would mean x cannot equal 2. And for the second one, that means x could not equal negative 2. Alright, the last thing we're going to take a look at is something called a complex fraction. A complex fraction is just a fraction that contains fractions within the fraction, as in the numerator is either a fraction itself or the denominator, or both of them are fractions. This is what a complex fraction looks like. There are two ways to be able to simplify a complex fraction. The first way to be able to simplify it is the fraction sign just means division. So really what you can do is you can write this out as a division problem. We're going to take this first part of our fraction, the numerator, 2 over x plus x over 4, and we're just going to write it out. Instead of saying all divided by, we're going to write it out sideways. Divided by x plus 1 over x. Well, if we want to be able to divide this, remember, to divide by a fraction, you have to multiply by its reciprocal. So this is really 2 over x plus x over 4 multiplied with x over x plus 1. Well, if we actually want to multiply this out, what we really want to do then is go through and just let's simplify what's in the parentheses here. Order of operations says we should do what's inside the parentheses before we multiply. So let's go through and combine these two. Our two denominators are x and a 4. They don't have anything in common. We just want to take and make sure that our least common denominator contains each one of those. So our least common denominator needs to contain an x. Least common denominator needs to contain a 4. So least common denominator is going to be 4x. Other way to think about that is when you can't find that least common denominator, you're not sure what it is, just take the two denominators itself and you can multiply them together, and that will get you a common denominator. In this case, it would also be the least common denominator. So we go through and say our least common denominator is going to be 4x, which means this is already an x, so we're going to have to multiply by the 4, multiply the top by 4. gives us 8. Down here, we have the same thing. If we have an x, or we have a 4, we need to throw in the x, so we multiply by x times x gives us x squared, and then we still have that whole thing being multiplied by x over x plus 1. 8 plus x squared is just 8 plus x squared over that 4x, and then we can say multiplied, don't need those parentheses anymore, multiplied by x plus 1. Well, remember what we talked about before. When you multiply two fractions, you can go through and reduce before you actually multiply. Do we see anything in the numerator or denominator that can be reduced? We have an x in the numerator and an x down here contained again through multiplication that in the denominator that we can go through and cancel those out, leaving us with just a 1 here and a 4 down here. 8 plus x squared times 1 is going to be 8 plus x squared over 4 times x plus 1 is just going to be 4 times x plus 1. You can go through and simplify out this denominator if you want to. You don't have to, though we can leave it as that. It says assume that all expressions are defined, so we don't have to worry about where denominators would be equal to 0 within this problem. There's our final answer. The other way to be able to do this problem is we don't always have to write this out as a division problem, as in the numerator divided by the denominator and multiplied by the reciprocal. The other way that we can do this is we can find that least common denominator for all of the denominators and go through and multiply through by that least common denominator. So if we take a look here, we really have 3 denominators. We have an x, we have a 4, and we have an x. Well, the least common denominator between all 3 of those, well, we have to have an x, we have to have a 4, and then we just have to have an x, which we already said that we have the x there. So the least common denominator between all 3 of these will be 4x. What we can do with that is we can take this complex fraction and we can go through and multiply the numerator and the denominator by that least common denominators. And we can go through and multiply numerator, denominator by 4x. When we multiply that then, we can take that numerator and multiply 2 plus x over, or 2 divided by x plus x over 4. We can multiply that with the 4x, and then we could take the other denominator and multiply that by 4x as well. Well, when you multiply by 4x, this is basically like saying 4x over 1, which if we take this and we distribute this through, 2 divided by x multiplied with 4x over 1 plus, then we take that same exact thing, 4 over x, or x over 4 times 4x over 1. And then in our denominator, we have x plus 1 over x times 4x over 1. Well, if we go through and multiply each one of these out one at a time, we can go through, take a look, x in the denominator, x in the numerator. Those cancel each other out, and it just becomes 2 times 4 over really just 1, which we don't really need to have the 1. So it's just 2 times 4 is 8. We go here, do that same exact thing. We have a 4 in the denominator with the numerator. We can cancel that out. We don't really need the 1. And all we have left is x times x. So that's going to be x squared. So 8 plus x squared over, and then here we do that same exact thing. X in the denominator, x in the numerator. We don't really need the 1. For x plus 1 times 4, we can just write it as 4 times x plus 1. And there would be our simplified answer, which if we think about it, the last problem that we did, same exact one, we got that same exact answer. It's just a different method to be able to do this. Where if we find that least common denominator, what happens when you find that least common denominator is when you distribute that, all of the original denominators that we had cancel each other out and it no longer becomes a complex fraction. So we are going to stop there. We'll take a look at the last problem in class.